Okay, so in this video, we're going to quickly, or not quickly actually, just talk about how to start solving these OSM problems. So to do this, we're going to use the Marine Weekly case as an example and then go through this step by step. And this is all going to be done on paper and just by looking at this. And I would strongly recommend that in your early days, this is the process that you follow for every single OSM problem before you move to coding. And it will make it much easier for you. So if you've not read the Marine Weekly case, would strongly recommend doing so. But in essence, what's happening is that you have a website. This website has 3 pages. So let's go here. So these are the 3 different web pages right here. So you have news, travel, and sports. On each web page, you have to serve an ad. And you have 5 ad providers. So 1, 2, 3, 4, 5. And I'm going to refer to each ad provider by its abbreviated system. So advisors of Sausalito is AS, Bold Cruises BC, etc., etc. So in each of these 3 web pages, you can serve any of these ads. And the question you've been asked is, well, how do you decide what ad to serve, or how many times each ad should be served on each page such that you can make the most amount of money? Cool, so now that we know this, let's follow through the OSM process. So the process I like to follow is, the first thing I do is define your decision variable. So in this case, what is a decision variable? A decision variable is basically what the answer is that you're looking for. And the answer that we're looking for is, well, on each of these pages, how many of each ad is shown? So tactfully, let's do a deep dive into this. So decision variable. Great. So we have 3 sections. Right, so we have news, what is it, travel, news, travel, and sports. And for each of these sections, you can have 5 different ads. So you have ads, so let's quickly go through this. And essentially on the news page, 5 different ads can be shown. So AS, BC, CT, T-Mobile Wireless, and Figaro. And then similarly on the travel page, 5 different ads can be shown: AS, BC, CT, T-Mobile Wireless, Figaro, Advice Sausalito, Bold Cruises, Cool Tickets, DWFO, right? And what we're solving for is, on the sections page, how many Advisor Sausalito ads will be shown, how many Bold Cruises ads will be shown, etc., etc. So this is what we're solving for. So let's remove this. So this is the decision variable, right? This column here, or whatever number goes in each of these, is what your decision variable is. So going back up, the first thing that you want to do in defining a decision variable is 1.1, is you want to say how many. And so the answer, the way it looks like, is you have, well, 3 sections times 5 ads equals to 15 decision variables. Right? That makes sense because we have 3 sections, 1, 2, 3, and for each of those sections there's 5 ads, so we have to decide how many ads will be shown on each page. 15. Oh, I missed an O here. Cool. So now that we have that, what we want to do is, this is in English. Oh, let's use a different color here. Let's use purple. So this is in English. Now what we want to do is put it in math. So how do we put in math? Let's go back down here. So a variable, obviously, looks like this, right? This is a variable. So x is a variable. But how do we differentiate between all of these different x's, right? We could keep doing x, y, z, but then we run out of alphabets, and then we have to start again with a, I guess. But this is not scalable, so let's just call it x. So the way we differentiate it is we give it a subscript. So x, this variable would be x subscript news, comma, as. This would be news, comma, bc. Essentially saying is that this variable refers to the news, and the Advisor Sausalito page. So this is how you define the subscript. But in mathematics, well, how do you refer to all of these decision variables that are here in one go? Well, the title of this would be your decision variable x. And what we do is in the subscript, we write S for section, comma, A for ads. So this is saying that x, S, comma, A refers to all of these decision variables, where S can be any of these three, right? So 3 options for S and 5 options for A, which obviously equals to 15 permutations or whatever combinations, right? That makes sense. Super. So going back up here in mathematics, the way we write it is decision variable will be shown as x subscript S A. So this is a decision variable. Once you have that, that's a lot of marks already. How about we do the second thing, which is define objective. Oh, sorry. One more thing we have to do up here before define objective is, well, we have this decision variable. We have to give it properties. So its lower bound is 0, and it's a type integer, right? It makes sense. I mean, you can't serve half an add, so the type has to be integer, and the lower bound is 0. And any other properties you want to give it here, like upper bound, etc., would all go in this section of your mathematics. Cool. So now let's move on to the second step. Second step is to define the objective. So again, the first thing we do is we define it in English. So in English, our objective is to maximize revenue. Revenue. Perfect. Well, that's pretty easy to say, right? Don't we all wish we could maximize revenue? But the question is, well, what is revenue? So this is where we sort of get into the English and math. Well, revenue is equal to how many ads I've served times the profit that I make, or the revenue that I get per serving, times the click-through rate. So now what we can do is write in English, revenue is equal to number of ads served times click-through rate times revenue per click for that ad, right? So you have 3 things that are multiplied by each other. So let's go back, and now the second step is obviously to put it in math. So this is where this gets slightly more difficult. So how do we show this equation? So the first thing is, well, we have number of ads served. How do we show number of ads served? Well, it's pretty easy because this is what our decision variable was, right? X sub S comma A tells us how many ads were served for a specific section and a specific advertiser on that section. So number of ads served is X sub S comma A. Perfect. Then what's click-through rate? Well, times click-through rate. Our click-through rate is defined here. These are our click-through rates. So again, click-through rate will also be sub S comma A, right? Because for news and AS, there's a specific click-through rate. For news and bulk cruises, there's a specific click-through rate. So I guess what you could say is, over here, there's also a click-through rate number, which is fixed, S comma A, right? I guess this would be 0.04, news AS, this would be 0.03, etc. So these are fixed, right? That's what these click-through rates are. So again, we show this as a variable, which is, it can change. And then the last part is the revenue per click for that ad. So in English, or in math, I guess this is times revenue, which I think in this case has been fixed to 10 cents. So you could also write this as, well, let's just leave it, for now, let's just leave it as variables. Okay, but this is not enough yet, because this equation is, it's in variables, so we have to now do sums. So what sum means is, if we go down here, we should move these over. If we were to calculate the revenue for each row here would look like X news sub AS times 0.04 times 10 cents, right? And then this would be times here, 10 cents. Times here, 10 cents, right? And at the end of it, what we would do is sum this entire column. So if this equals, then we would sum this entire column, and we would get a final number here. So what this thing here shows us is only one of these rows. But what we want to do is we want to show it for what happens when you sum over all of them. So the way we do this is we use the sum sign. So we add a sum sign here. And what we're saying is we're summing across all advertiser. But we're not only summing across all advertisers, right? Because we're not only summing, if we sum across all advertisers, that's only this part, because there's 5 advertisers. But what we're doing is summing across all advertisers for also each section. So the way we do this is, well, summing across all advertisers, this becomes one equation, but also summing across all sections. So this becomes another equation, right? So this loop here will run 5 times because there's 5 of these. So this will be 5 times. And then this entire thing here will then run 3 times because there's 3 different sections. So in essence, this is showing mathematically in one line the sum. But this part is just equal to this part of this equation, revenue. So now what we want to do is we want to say, well, maximize, right? Because that's our objective in mathematics, is maximize. So what we do is simply put a max here. So our objective in math is to maximize the sum across all sections and the sum across all advertisers to be our decision variable times the click-through rate times the revenue. Again, that is a ton more points. So now let's move on to constraints, which is the third thing. So constraints. So for constraints, let's just go through, we'll show the first one as an example. So here it says, these are the restrictions, the constraints, that at least 12,000 page views in total should be shown for the company advisors of Sausalito. So going back to our list of things here, let's remove this ugly circle. This thing here, okay. So going back here, advisors of Sausalito basically want at least 12,000 page views. So where does advisors of Sausalito occur? They're happening here, here, and here, right? So this is X sub travel, comma, AS, and X sub sports, comma, AS. So essentially what this thing here is saying is they want X sub news, comma, AS, plus X sub travel, comma, AS, plus X sub sports, by sub I mean subscript, comma, AS, is greater than or equal to 12,000, right? That's what they're essentially saying. So how do we show this? So, sorry, in constraints, we go back here. In English, whoops, wrong color. Is it? In English, it would be at least 12K AS ads, right? So in math, oh, sorry, that should have been black, whatever. in math, how do we do this? Well, in math, we have the equation here, but this is not ideal. So let's go up here. Paste this here. Okay, sure, why not? So this is not very ideal because this can be simplified. So how do we simplify it? Well, what we do is we say x sub s, comma, as. And let me explain why. Because in this case, news, travel, and sports, the sections are changing, but as is fixed each time. So what we're saying is when we say x sub s, as means as is fixed, but s will change. And here we're summing, right? We're summing them. So again, we put a sum sign. And this way, the subscript here will be, if you've figured out and you're following, it will be sub s because there are 3 different sections, right? And this sum has to be greater than or equal to 12,000. So this here is a better way. This here is a better way of writing this. So can I delete this? That's lame. Okay, whatever. I can't delete this. So this is how to do constraints. Let's just remove this. This is how you would do constraints. So now the second one is out of which at least 18,000 a new section, right? So basically, if we do second one here, we go back down here. What they're saying is that the new section at Sausalito should be at least 8,000, right? So this should be at least 8,000. So the way we do this is this next constraint here in math would be x sub news sub as has to be greater than or equal to 8,000. And here we don't need a sum sign. Why don't we need a sum sign? Because this is specifically talking about just one of our decision variables. This is not going through other decision variables. So using this system of like summing and whatnot, you can do all of the other ones. But quickly, let's just talk about a different way you can show it. If you don't like the sums, let's take this one. So let me copy this. And let's just talk about a different approach. Okay, so approach 2 is you can say that you have x sub s, comma as, and you can say for s in sections, we do sum of as is greater than or equal to 12,000. Well, I guess you could put it, yeah, it'll all be in one line. Because what you're saying is there's 3 sections, right? So for each s in sections, you will sum all the different variables here, and that has to be greater than 12,000. This is another way to show this mathematically. I like this one better, but you guys can also do this. So now that you have this, right, you have your decision variables, you have your objective defined, and you have your constraints defined. And now if we look at the Marine Weekly starter thing that was given to us, or the answers, you'll notice that this is very similar to what they've done. The first thing they've done is decision variables, and they've done x sub a. So now we know what this means, x sub a. They've also given the objective, which is maximize total revenue, which is this, right? And that is also very similar to what we've done, which is sum of s, sum over a of the exact same formula. And then they have constraints. So we've only gone through 2 of the constraints, 1 and 2, but they have the the things for all the constraints. Now, for these decision variables, we can also talk about how to use add_var versus add_vars for these decision variables, and we'll also talk about this, I guess, in a separate video of how to make a nonlinear equation into a linear equation for this problem. Great, I hope this was helpful. I would follow this exact process for every single problem that you have, because from here it's easier to code because you actually understand what you're doing, and then you can start referring to each one of these as variables in your code.